All right, welcome back from vacation. We're going to dive into trigonometric identities today. And I think it may be a little bit confusing. It isn't ideal that we're getting into a fairly confusing topic first day after a long vacation, but it's what we're going to do. And I think one thing that you should make use of in today's work is the fact that the answer key for these things are here, and the answer key is a good one that gives you it shows you the steps and it shows you the solutions. And I think this is a good chance to, um, practice thinking about these things, get them as far as you can, and then look at the solutions and learn what you didn't know from looking at the solutions, because there's a lot of that with this concept. So the first thing with these trig functions, well, actually, let's say there's 6 trig functions. First is sine, next is cosine, and the third is tangent. You have seen these pretty regularly, but then there's 3 more, which are cosecant, secant, and cotangent. Okay, so the cosecant is 1 over sine, the secant is 1 over cosine, and the cotangent is 1 over tangent. So they're called the reciprocal trig identities, which means if I see secant of x is equal to 2 over root 2, and I'm asked to solve that equation, well, the secant is the reciprocal of the cosine, so I could take the reciprocals of both sides and say this is the same as solving the equation cosine of x is equal to root 2 over 2. Then you go find your unit circle. Root 2 over 2 is cosine is the x, whereas x, it's going to be somewhere like these two angles, whatever. I guess it'll be like these ones, I think. But you'll have to look at your unit circle to solve those. The Pythagorean identities is something that we touched on briefly, but maybe we didn't go into them too much. You're going to need these ones today. So the Pythagorean identity is that sine squared of x plus cosine squared of x, or if you're not into x, a lot of times you'll see this as theta. Doesn't matter, whatever that is, as long as it's the same thing, is always going to equal 1. Now, there's 3, count on 1, 2, 3 different trig identities. And the first one is always the first one. The second and the third one you get to by going through, if I divide this whole equation by sine squared of theta, what is that going to equal? Well, that's going to equal sine squared over sine squared is 1. Cosine squared over sine squared, that's cosine over sine, which is sine over cosine is tangent, remember? So cosine over sine is cotangent. So this is 1 plus cotangent squared of theta is equal to 1 over sine is cosecant. So this is cosecant squared of theta. That's one of the 3 Pythagorean identities. Now we got 2. So you may be thinking to yourself, what am I going to do to get the other one? Oh, obviously, if I went through and divided by sine squared the last time, this time I'm going to divide everything by cosine squared. So that is going to be sine over cosine, which is tangent squared of theta, plus cosine squared over cosine squared, that's 1, is equal to 1 over cosine squared, which is secant squared of theta. And notice that with these Pythagorean identities, you can also manipulate them a little bit, like cotangent squared of theta is equal to cosecant squared of theta minus 1. All I did was minus 1 from both sides. So you have to know that there's these 3 trig identities, Pythagorean identities out there. You'll notice when you have things where they're squared, you'll start thinking about using the Pythagorean identities. And notice that with each of these 3 equations, you can manipulate it a little bit to allow you to do different things. So how does that play out? Well, let's just look at what you're going to be doing on these. This is solving trigonometric equations. This is the worksheet. For some of them, you're just going to be like, if I start going down this road, I'm going to get to, I think, cosine of x is equal to root 3 over 2. And then you'll just have to go into your unit circle to figure out what those things are. It says for all possible values and degrees, which means there's infinitely many. Sometimes you're going to have a squared here. So let's say this is 4 sine squared is equal to 3 sine squared is equal to 3 over 4. Sine is equal to root 3 over 2. Remember, when you take the square root of anything, you're going to give positive and negative possible solutions. So I think we did this very briefly earlier in the year, but when you have a squared and you take the square root, it leaves you with more possible solutions than if you didn't. Okay, so now let's look at some other ones. For something like this, this is factor the greatest common factor. If I factor out cosine theta, I get 2 cosine theta times 2 sine theta is equal to cosine theta. So what I'm essentially going to do is divide both sides by cosine theta, and I get 2 sine theta is equal to 0. But keep in mind that when I divided by this, I eliminated, not cosine theta is equal to 0. I guess 2 sine theta is equal to 1. But so there's going to be possibilities that this yields or suggests, but another possibility that I should keep in mind when I divide everything by cosine theta like that is, well, if I hadn't gotten rid of cosine theta, if cosine theta is equal to 0, no matter what sine is, that's going to make that equation true. Sometimes you can factor these things, like if it said 2x squared minus 3x plus 1 is equal to 0. How do I get that? I'm going to get 2x and x, and I'm going to get, I think, minus 1 minus 1. So I could call this 2 sine of x minus 1 times sine of x minus 1. And that gives you some stuff to solve. It's going to give you many solutions. And then where it says rewrite with a single trig function, if you see these things and you have squares and you have multiple, then you have to use one of your Pythagorean identities. So 3 secant squared minus 2 tangent squared. Let's see. Secant squared is equal to tangent squared plus 1. So why don't I just say this is going to be 3 times tangent squared of x plus 1 minus 2 times tangent squared of x minus 4 equals 0. And then see where I can get to from there. Let's see. Square and convert to quadratic type. Well, I'm going to square it. So in this thing, I'm going to square it. And then when I do that, I get sine squared plus 2 sine plus 1 is equal to cosine squared. And I don't know exactly where. Well, you could plug in sine squared plus cosine squared for 1. You could shift things around. I don't know how that one's going to work out, but what they're saying by square and convert to quadratic type is square both sides. So these things are giving you hints, and then at the bottom, you're given just a lot more examples. I think these things, you just sort of need to practice them. Remember that when you're frustrated, that's oftentimes your brain doing exercise. So um, remind yourself it's good to be frustrated. The solutions are out there. You don't want to go straight to the solutions because you'll trick yourself into thinking you learn everything the same way. But what you really learn is from the process of getting yourself confused and then getting yourself out of it. Okay, good luck, everybody.